Hello everyone, I'm Nitishas and welcome to the section of Grade 9 CBSE Maths class. Today we are looking at the chapter number 8, Quadrilaterals. Chapter number 8, Quadrilaterals. So, what do you mean by a quadrilateral? That's the basic thing. From the answer of that question, we can start the chapter. What do you mean by a quadrilateral? You all think the answer in your mind and just be ready to answer the question. What is a quadrilateral? What is the answer? Now, the answer came from your mind that a quadrilateral is a closed figure having 4 sides, 4 angles and 4 vertices. A quadrilateral is a closed figure having 4 sides, 4 angles and 4 vertices. Clear? You all studied regarding polygons in class number 8, grade 8. You all studied about polygons. These polygons includes triangles, quadrilaterals, pentagon, hexagon, heptagon, octagon, nonagon, etc. Here, in all these polygons, we know that if we are considering a triangle, we have 3 sides and 3 angles. And in a chapter, whole chapter related to these triangles, we are going to study all the topics, all the specialities or all the features of a triangle. Then triangle is a polygon having 3 sides. So the next category is a polygon having 4 sides, and that category is called as quadrilaterals, and that category is called as quadrilateral. So we can simply explain this quadrilateral as a quadrilateral is closed figure. All the polygons are closed figure. No open figures can be called as a polygon. So this quadrilateral also a closed figure having 4 sides, 4 angles and 4 vertices. So I am considering a closed figure with 4 sides, 4 angles and 4 vertices. Now I am going to name it as A, B, C, D. So this ABCD is a quadrilateral. Now look, AB is one side, BC is second side, CD is third side and DA is fourth side. So we are having 4 sides, AB, BC, CD and DA. These are the 4 sides of the quadrilateral. Now look at the angles. Here angle A, here angle B, here angle C and here angle D. 4 angles are there, angle A, B, C and D. These are the 4 angles. And also these are the 4 vertices. Vertex A, vertex B, vertex C and vertex D. These are the 4 vertices of the quadrilateral. So it is a closed figure having 4 sides, having 4 angles and having 4 vertices. Then this can be called as a quadrilateral. This is what you mean by a quadrilateral. So whenever you are having a question, what is a quadrilateral, or your friend or anyone else asked you to answer what is a quadrilateral, then you can simply say that a quadrilateral is a closed figure having 4 sides, 4 angles and 4 vertices. That's simply a quadrilateral. Now, in the property, we say that a quadrilateral have 4 angles. The property, we already said that a quadrilateral have 4 angles. Then, what will be the sum of these 4 angles? That's what called angle sum property of a quadrilateral. Angle sum property of a quadrilateral. Angle sum property of a quadrilateral. What is angle sum property of a quadrilateral? Now I am again considering a quadrilateral. This is our quadrilateral. Just name it as A, B, C, and D. Okay. This is our quadrilateral. Now we all know that we are having four angles: angle A, angle B, angle C, and angle D. Now we have to find what is the value of angle A plus, angle B plus, angle C plus, angle D. What is the value of angle A plus, angle B plus, angle C plus, angle D? How will you find this? The sum of all the four angles. So we can easily found it by drawing a diagonal. I am drawing a diagonal from A to C. So this diagonal AC divides the whole quadrilateral into two triangles. This diagonal AC divides the whole quadrilateral into two triangles AC. Now we are having two triangles, triangle ADC and triangle ABC. Then what is the sum of the angles in a triangle? Sum of the angles in a triangle is 180 degree. You all know that sum of the angles in a triangle is 180 degree. Therefore, in triangle ADC, we can say that angle D plus angle DAC plus angle DCA is equal to 180 degree. That means this angle, and this one. These three angles togetherly makes 180 degree. So in triangle ABC, now look at the triangle ABC. In triangle ABC, all the three angles, that is angle B plus angle BAC plus angle BCA is equal to 180 degree. Because in a triangle, the sum of the interior angles is 180 degree. In a triangle, the sum of the interior angles is 180 degree. That's why we are saying that the triangle, all the three angles togetherly makes 180 degree. So in this triangle, total angle is 180 degree. And in this triangle, total angle is 180 degree. Then what is the total angles of the whole quadrilateral? These two triangles togetherly make the quadrilateral. Therefore, sum of the angles in a quadrilateral is this 180 degree plus this 180 degree, that is 360 degree. So we can say that sum of the angles in a quadrilateral, sum of the angles in a quadrilateral is 180 degree plus 180 degree, that is equal to 360 degree. So angle sum property of a quadrilateral says that the total interior angle of a quadrilateral or sum of the angles in a quadrilateral is 360 degree. This is one method to find the total sum of angles in a quadrilateral. Otherwise, we can use an equation. The sum of the interior angles of a polygon is found out by using the equation n minus 2 into 180 degree. Otherwise, we can use the equation n minus 2 into 180 degree. This is the equation for finding total sum of the angles in a polygon. This is the equation for finding total sum of the angles in a polygon, where n is the number of sides, Here we are considering a quadrilateral where number of sides is 4. Here we are considering a quadrilateral where number of sides is 4. So in place of n we can substitute 4. Therefore it becomes 4 minus 2 into 180 degree, that is equal to 2 into 180 degree. 2 into 180 degree is 360 degree. 2 into 180 degree is 360 degree. Same answer. in both methods. So when we are given a quadrilateral and finding the total angles in a quadrilateral, we can use either first method, that is drawing a diagonal and splitting it into two triangles. The sum of the angles in a triangle is 180 degree. Therefore, sum of the angles in both the triangles is 180 degree plus 180 degree, that is 360 degree. The second method is that sum of the angles in a polygon is found out by using the equation n minus 2 into 180 degree, where n is the number of sides. Here for a quadrilateral, number of sides is 180, number of sides is 4. So 4 minus 2 into 180 degree, that is 2 into 180 degree, it becomes 360 degree. So you have to memorize that the total angle in a quadrilateral or sum of the angles in a quadrilateral is always 360 degree. For any type of quadrilateral, the sum of the angles in it is 360 degree. Sum of the angles in it is 360 degree. Clear? Now I am going to draw some quadrilaterals and try to explain the features of that quadrilateral. Now I am going to draw some quadrilateral and try to explain its features. Okay. Now first type of quadrilateral. I am drawing a quadrilateral like this. This is our first category. I will name it after drawing all the figures and then we will discuss about the features. Then moving to the second one. This is our second quadrilateral. Moving to the third. This is our third one. And moving to the fourth. This is our fourth one. And then moving to the fifth. This is our fifth one. And moving to the sixth. This is our sixth one. These are, all these are quadrilaterals. All these are quadrilateral. But look at the shape. The shape of all these 6 1 varies. But all these have 4 sides and 4 angles and all these are closed figures. So we can call it in general, these all 4 are quadrilateral, but they are having some specific features. So we have to look at the specific feature of each of the given quadrilateral. So what is the special feature or specific feature of the first quadrilateral? In the first quadrilateral, this side and this side are parallel to each other. So when I am naming this A, B, C, D, we can say that AB parallel to CD. AB parallel to CD. Now look, one of the pairs of opposite sides are parallel. One of the pairs of opposite sides are parallel. If in a quadrilateral, one of the pairs of opposite sides are parallel and the other opposite sides are equal, and the other opposite sides are equal in length. Other opposite sides are equal in length because the distance between two parallel lines are always equal. So we can say that if one of the pairs of opposite sides are parallel to each other, then this quadrilateral can be named as a trapezium. trapezium. Then this quadrilateral can be named as a trapezium. So first figure is trapezium. First figure is trapezium. Now moving to the second figure. I'm also naming it as A, B, C and D. Now look at this. AB parallel to CD. Here in this figure, AB parallel to CD and also AD parallel to BC. That means opposite sides are equal and parallel. Opposite sides are equal and parallel. If opposite sides are equal and parallel, then this quadrilateral can be named as a parallelogram. Then this quadrilateral can be named as a parallelogram. Then this quadrilateral can be named as a parallelogram. Now moving to the third one, I'm also naming it as A, B, C and D. Now what is the specific feature of this? AB parallel to CD. First feature is AB parallel to CD. Second is AD parallel to BC. Second is AD parallel to BC. Any other features? Now look, all the angles are right angles. All the angles are right angles. All the angles are right angles. That means all the angles are 90° each. Here opposite sides are equal and parallel and all the angles are right angles. If opposite sides are equal and parallel and all the angles are right angles, then this quadrilateral can be called as a rectangle. Then this quadrilateral can be called as a rectangle. Now look at the fourth figure. We can name it as same name A, B, C and D. What is the feature of this? Here we can say that opposite sides are parallel. That means AB parallel to CD, then AD parallel to BC. Any other feature? Here AB, BC, CD and DA. That means all four sides are equal. All sides are equal. All sides are equal. Here the specialty is that opposite sides are parallel and all four sides are equal. Opposite sides are parallel and all four sides are equal. Then this quadrilateral can be called as a rhombus. Then this quadrilateral can be called as a rhombus. Now look at the fifth figure. What is the specialty? Same name we can give an A, B, C, D. What is the specialty here? Here AB parallel to BC, sorry, AB parallel to CD and AD parallel to BC. Same condition, opposite sides are parallel. Opposite sides are parallel. Then AB, BC, CD and DA. That means all sides are equal. All sides are equal. Now these are the condition which is similar to rhombus. Then any other specialty for this figure? Now look, all the angles. All angles are right angles. All angles are right angles. Here opposite sides are parallel. All sides are equal and all angles are right angles. Opposite sides are equal. Opposite sides are parallel. All sides are equal. All angles are right angles. Then this quadrilateral can be called as a square. Then this quadrilateral can be called as a square. Now look at the last figure. What is the specialty of this? We can give the same name A, B, C and D. Now what is the specialty? AB is equal to BC. AB and BC are equal to each other. Then AD is equal to CD. AD and CD are equal to each other. That means pair of adjacent sides are equal. Pair of adjacent sides are equal. Then this figure can be called as a kite. Then this figure can be called as a kite. These are the classification of quadrilaterals. That means trapezium, parallelogram, rectangle, rhombus, square and kite. Now look at again the figure. What is a trapezium? In trapezium, A pair of opposite sides are parallel. Pair of opposite sides are parallel. And the other opposite sides may be equal. Then this can be called as a trapezium. In the next one, it is a parallelogram. What is the peculiarity of a parallelogram? Opposite sides are equal and opposite sides are parallel. Opposite sides are equal and opposite sides are parallel. Now look at the third one. It is a rectangle. For a rectangle, opposite sides are equal, opposite sides are parallel, and all angles are right angles. Then next is a rhombus. Specialty of rhombus is that all the four sides are equal, opposite sides are parallel. If opposite sides are parallel and all the four sides are equal, then it is a rhombus. Next, for a square, opposite sides are parallel, all the four sides are equal, and all angles are right angles. And all angles are right angles. Then for a kite, pair of adjacent sides are equal. That is AB is equal to BC, AD is equal to CD. Then it is a kite. So trapezium, parallelogram, rectangle, rhombus, square, and kite. Clear? If in a parallelogram, if the angles become 90 degree, then it will become a rectangle. That means rectangle is a special case of a parallelogram. A rectangle is a special case of a parallelogram. So when we are considering a rectangle and all the four sides of a rectangle are equal, then it becomes a square. So square can also be called as a special case of a rectangle. Now look at the rhombus. In a rhombus, if angle becomes 90 degree, in a rhombus, if an angle becomes 90 degree, then it simply becomes a square. So square can also be called as a special case of a rhombus. So these parallelogram, rectangle, rhombus, and square, these four figures are interrelated figures. These four figures are interrelated figures. These are the classification of quadrilateral, and this is the basic thing of this chapter. Now, after studying the basic or after understanding the basics of quadrilateral, then you can able to solve all the problems related to this chapter. So now we have to move through some properties of parallelogram and the theorem related to that, and then we can solve some problems. Clear? Next to the basic of quadrilaterals, we need to study properties of a parallelogram. That's an important topic in this chapter, properties of a parallelogram. You all know what a parallelogram is. Now you are able to explain or discuss or define a parallelogram. Okay. When we are explaining all the quadrilaterals, that is a parallelogram, a rhombus, a square, a rectangle, a kite, or a trapezium, we discuss the properties of that figures. Now, parallelogram is one of the important quadrilaterals and having some more importance than other the quadrilaterals. So, we have to study the properties of a parallelogram more importantly. And this is an important chapter in this, important topic in this chapter. So, we are having 7 theorems related to properties of a parallelogram. We are having 7 theorems related to properties of a parallelogram. We can look into it one by one. The first theorem in this chapter is a diagonal of a parallelogram divides it into two congruent triangles. When we are considering a parallelogram and when we draw a diagonal to the parallelogram, when we are considering a parallelogram and when we draw a diagonal to the parallelogram, then that diagonal divides the parallelogram into two congruent triangles. What do you mean by congruent triangles? For a congruent triangles, all the corresponding parts are equal. That simply we can say that CPCT. What CPCT means? CPCT means corresponding parts of a congruent triangle. Corresponding parts of a congruent triangles are equal. When we are considering two congruent triangles, all the three sides and all the three angles are equal. So, The diagonal of a parallelogram divides the parallelogram into two congruent triangles. That is, that diagonal gives us two congruent triangles which are of equal length and equal angles. That's the first theorem. Now what is the theorem number 2? Second theorem. In a parallelogram, opposite sides are equal. That we all know that when we are considering a parallelogram, opposite sides are equal. Opposite sides are equal for a parallelogram. Then what is theorem number 3? If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. So theorem 2 can be stated otherwise. In theorem 2, it states that in a parallelogram, opposite sides are equal. This theorem 2 can be stated in other words that if each pair of opposite sides of a quadrilateral is equal, when we are considering a quadrilateral, each pair of opposite sides is equal, then it is a parallelogram. Then it is a parallelogram. This is theorem number 3. And what is theorem number 4? In a parallelogram, opposite angles are equal. In a parallelogram, opposite angles are equal. Then next theorem number 5. If in a quadrilateral, each pair of opposite angles is equal, then it is a parallelogram. That means theorem 4. In theorem 4 states that opposite angles of a parallelogram are equal. It can be stated otherwise that when we are considering a quadrilateral, in that quadrilateral, each pair of opposite angles is equal, then it is a parallelogram. Each pair of opposite angles is equal, then it is a parallelogram. Then what is theorem number 6? The diagonals of a parallelogram bisects each other. The diagonals of a parallelogram bisects each other. What do you mean by bisects each other? It will cut exactly into two equal parts. Bisect each other means it will cut exactly into two equal parts. So, when we draw two diagonals for a parallelogram, these two diagonals exactly cut each other into two equal parts. That means it will exactly bisect each other. So, this theorem 6 can also be stated in other words such that if in a quadrilateral, the diagonals bisect each other, then it is a parallelogram. If in a quadrilateral, the diagonals bisect each other, then it is a parallelogram. That is theorem number 7. These are 7 theorems, or otherwise we can say that these are the 7 properties of a parallelogram. These are the 7 properties of a parallelogram. Each property is stated as a theorem here. Each property is stated as a theorem here. Then now these are the 7 theorems. Now we can say the properties, or we can explain the properties one by one. As first one is diagonal of a parallelogram bisect it into two congruent triangles. Second one, opposite sides of a parallelogram are equal. Third one, if opposite sides of a quadrilateral are equal, then it can be called as a parallelogram. Fourth one, opposite angles of a parallelogram are equal. Then fifth one, if opposite angles of a quadrilateral are equal, then it can be called as a parallelogram. Next, sixth one, diagonals of a parallelogram bisect each other. Seventh one, we can state that if the diagonals of a quadrilateral bisect each other, then it can be called as a parallelogram. These are the properties of a parallelogram. These are the properties of a parallelogram. Clear? Okay. Now we are going to solve some problems related to the theorems we have studied. We already studied 7 theorems related to the properties of a parallelogram, and before studying theorem, we go through some properties of quadrilaterals. Okay, based on what we have studied, we can now solve some problems. First question is that show that each angle of a rectangle is a right angle. Show that each angle of a rectangle is a right angle. So this is a proof based question. That means the condition in the question have to be proved by ourselves. The condition is that each angle of a rectangle is a right angle. So we have to prove the all angles in a rectangle are 90 degree each. And remember the condition that what is a rectangle? A rectangle is a parallelogram in which one angle is 90 degree. That's the condition that we already studied. The difference between parallelogram and rectangle is that rectangle is a special case of a parallelogram in which one angle is 90 degree. So we can say that a rectangle is simply a parallelogram in which one angle is 90 degree. Clear? So now I am considering a parallelogram with one angle 90 degree. I am considering a parallelogram with one angle 90 degree. And this is my parallelogram. I am naming it as A, B, C, D. And one angle is 90 degree. That means angle A is equal to 90 degree. Okay. A rectangle is a parallelogram. Simply a parallelogram with one angle 90 degree. So I am taking A as 90 degree. Now we have to prove all the angles are of 90 degree. That means we have to prove angle B, angle C and angle D are 90 degree. That we need to prove. Angle B, angle C and angle D are 90 degree. That we need to prove. How will we prove these three angles B, C, D are 90 degree? How will we prove? Just go through some properties related to parallelograms. What are the properties related to parallelograms? We know that opposite angles in a parallelogram are equal. Opposite sides are equal. Before that, we can use, here we know that opposite sides of a parallelogram are parallel. Now I am taking the property opposite sides of a parallelogram are parallel. Therefore, we can say that AD parallel to BC. AD parallel to BC. This is the property of a parallelogram, that opposite sides of a parallelogram are parallel. Now AD parallel to BC and AB is the transversal and AB is the transversal. So when a transversal intersects or meets two parallel lines, we know that alternate interior angles are equal. Interior angles on the same side are supplementary. So now look at this figure. AD and BC are parallel and AB is the transversal. Therefore, angle A and angle B are on the same side of the transversal, or same side interior angle, same side. Angle A and angle B are the interior angles of the same side of the transversal. So the sum of angle A and angle B should be 180 degree. That is, we can say that angle A plus angle B is equal to 180 degree. How will we get this 180 degree? We know that interior angles on the same side of the transversal should be supplementary. That's why I am writing angle A plus angle B is equal to 180 degree. We know that angle A is equal to 90 degree. So 90 degree plus angle B is equal to 180 degree. Therefore, angle B is equal to 180 degree minus 90 degree, that is equal to 90 degree. Now we got angle B as 90 degree. Now we got angle B as 90 degree. So angle A is equal to 90 degree, angle B is equal to 90 degree. Now look at another property of a parallelogram such that opposite angles are equal. For a parallelogram, opposite angles are equal. Therefore, we can say that angle A is equal to angle C. Angle A is equal to angle C. Here angle A is equal to 90 degree. Therefore, angle C is also 90 degree. Now we got angle C as 90 degree. We already find angle B as 90 degree. By the property of parallelogram, we can say that opposite angles are equal. Therefore, angle B is equal to angle D. We know that angle B is 90 degree. That is, angle D is also 90 degree. That is, angle B is D is also 90 degree. Now look at the figure. All the four angles become right angles. All the four angles becomes right angle. Therefore, in a rectangle, we can say that all the angles are of 90 degree. Otherwise, we can say that each angle of a rectangle is a right angle. Hence, we proved it. Okay. Now moving to the next question. What is the next question? Show that the diagonals of a rhombus are perpendicular to each other. Show that the diagonals of a rhombus are perpendicular to each other. So we have to prove the diagonals in a rhombus are perpendicular to each other. So consider a rhombus first. First we are considering a rhombus. And this is our rhombus. And giving it name A, B, C and D. This is the name. So we have to prove the diagonals of this rhombus are perpendicular to each other. So draw two diagonals, AC and BD, and the meeting point of this diagonal is taken as O. How will we prove these both diagonals are perpendicular? You all know that if two line segments are perpendicular to each other, then the angle should be 90 degree. If two line segments are perpendicular to each other, then the angle should be 90 degree. So we have to prove both these angles are 90 degree. We have to prove both these angles are 90 degree. Clear? How will we prove this? We can consider the triangles AOD and COD. Consider triangles AOD and triangle COD. I am considering two triangles, triangle AOD and triangle COD. Now look at the figure. For a rhombus, all the four sides are equal. For a rhombus, all the four sides are equal. Therefore, we can say that AD is equal to CD. We can say that AD is equal to CD. Now, you all know that when the four sides of a parallelogram are equal, then it can be called as a rhombus. So, in rhombus also, the diagonals bisect each other. In rhombus also, the diagonals bisect each other. So, when the diagonals bisect each other, we can say that AO is equal to CO. AO is equal to CO. This is the property of a parallelogram, that diagonals bisect each other. When all the four sides of a parallelogram are equal, then it can be called as a rhombus. Clear? Now, look at the third side, OD. OD is equal to OD, which is the common side of both the triangles. For triangles AOD and triangle COD, OD is the common side. Therefore, we can say that OD is equal to OD, which is the common side. Now, what is the peculiarity of both the triangles? AD is equal to CD, AO is equal to CO, and OD is the common side. Therefore, three sides of this triangle are equal to each other. Three sides of this triangle are equal to each other. When all the three sides of a triangle are equal to all the three sides of another triangle, then both the triangles are congruent to each other. If all the three sides of a triangle are equal to all the three sides of another triangle, then both the triangles are congruent to each other. Therefore, we can say that triangle AOD congruent to triangle COD. Triangle AOD congruent to triangle COD. Triangle AOD congruent to triangle COD. Okay. For congruent triangles by CPCT. What is CPCT? Corresponding parts of a congruent triangle. What is CPCT? Corresponding parts of a congruent triangle. So, when two triangles are congruent, all the corresponding parts are equal. That means all the sides and all the angles are equal. The corresponding angles are equal. That we can say angle AOD is equal to angle COD. That we can say angle AOD is equal to angle COD. That means if we take angle AOD as X, then COD is also X. Both the angles are equal. Now look at the figure. This angle AOD and angle COD are linear pair. Angle AOD and angle COD are linear pair. You know that for a linear pair, the sum of the angles is 180 degree. Sum of the angles is 180 degree. Therefore, angle AOD plus angle COD is equal to 180 degree. Angle AOD plus angle COD is equal to 180 degree. The sum of the angles is 180 degree and both the angles are equal. The sum of the angles is 180 degree and both the angles are equal. Therefore, we can say that each angle is 90 degree. Therefore, we can say that each angle is 90 degree. Each angle is 90 degree. If each angle is 90 degree, then we can say that both the line segments are perpendicular to each other. That means here the diagonals are perpendicular to each other. That we have to prove. Hence, proved. Clear? For a rhombus, diagonals are perpendicular to each other. Hence, we proved this. Clear? Both the questions are clear? Okay. Moving to some more questions. Next question is that the angles of a quadrilateral are in the ratio 3:5:9:13. Find all the angles of the quadrilateral. We know that for a quadrilateral, there are 4 angles and the sum of the quadrilaterals, sum of the angles in that quadrilateral is 360 degree. That we all know that. We already proved that the sum of the angles in a quadrilateral is 360 degree. Here in this problem, the ratio of all the 4 angles is given as 3:5:9:13. We have to find all the 4 angles. So actually we didn't know the angles, only we know the ratios. So we take the angles as 3x, 5x, 9x and 13x. Let the angles be 3x, 5x, 9x and 13x. Let the angles be 3x, 5x, 9x and 13x. 3x, 5x, 9x and 13x. We know that the sum of the angles in a quadrilateral is 360 degree. That means 3x plus 5x plus 9x plus 13x is equal to 360 degree. 3x plus 5x plus 9x plus 13x is equal to 360 degree. Now just add it. 5 plus 3, 8. 8 plus 9, 17. 17 plus 13, it is 30. 30x is equal to 360 degree. Clear? 5 plus 3, 8. 8 plus 9, 17. 17 plus 13. Is equal to 360 degree. Now what is x? X is equal to 360 divided by 30. 360 divided by 30. These zeros can be cancelled. It will become 36 divided by 3. It is 12. Now we got x as 12. Now we can find all the angles. That is, first angle is 360. That is equal to 3 into 12. 12 into 3 is 36. So first angle is 36 degree. Next is 5x. 5x, that is 5 into 12. That is, next angle is 60 degree. And the third one, it is 9x. That is 9 into 12. That is equal to, what is 9 into 12? It is 108. Then last one is 13x. That is 13 into 12. What is 13 into 12? 13 into 10, 130. 13 into 2, 26. It is 156. Now check it is right or not. Just add 156 plus 108 plus 60 plus 36. 8 plus 6, 14. 14 plus 6, 20. Remainder 2. 5 plus 2, 7. 10 plus 3, 10. 10 plus 6, 16. Remainder 1. 1 plus 1 plus 1. That is 3. 360. Total angle is 360. That is, we solved it as right. That means the 4 angles are 36 degree, 60 degree, 108 degree and 156 degree. These are the four angles in the quadrilateral where the ratio is 3:5:9:13. Okay. Now look at the next problem. If the diagonals of a parallelogram are equal, then show that it is a rectangle. If the diagonals of a parallelogram are equal, then show that it is a rectangle. So consider a parallelogram, and if the diagonals of this parallelogram are equal, then we have to show it is a rectangle. So first we are considering a parallelogram. We are considering a parallelogram, and this is our parallelogram. I am naming it as A, B, C and D, and I am drawing both the diagonals. These are the diagonals, and meeting point is taken as O. Now, for a parallelogram, we know that the diagonals bisect each other. For a parallelogram, we know that the diagonals bisect each other. If the diagonals bisect each other, then we can say that just consider triangle AOD and triangle COD. Triangle AOD and triangle COD. For a parallelogram, the diagonals bisect each other. Therefore, we can say that AO is equal to CO. AO is equal to CO. Clear? Now, OD is the common side. Therefore, we can say that OD is equal to OD. Okay. Then what we have to prove? We didn't know that AD and CD are equal. Okay, this is a parallelogram. So what will we do next? We got two conditions, AO is equal to 0 and OD is the common side. Then next we know that the diagonals of the parallelogram are equal. Diagonals of the parallelogram are equal. The diagonals of this parallelogram are equal. These are the conditions we know that. And properties of a parallelogram are opposite sides are parallel, opposite sides are equal. Then diagonals bisect each other, opposite angles are equal. Then if AD and BC are parallel to each other and this BD is the transversal, then we can say that alternate interior angles are equal. Therefore, this angle and this angle are equal. Therefore, if it is X, this is also X. And when we are considering AB parallel to CD, alternate interior angles are equal. Therefore, if it is Y, then this is also Y. So what comes next? When we are considering this diagonal, alternate interior angles are equal. Therefore, this angle and this angle are equal. If it is A, this is also A. Then if it is B, this is also B. And vertically opposite angles are equal here also. If it is Z, this is Z also. If it is C, then this is C. These are all conditions we got from the figure. Now, how will we prove this? Now take one more example, or take another two triangles, triangle A, B, D and triangle A, B, C. What is the peculiarity of this? Triangle A, B, D. In triangle A, B, D, in triangle A, B, D and in triangle A, B, C, we know that AB is equal to AB, common side. Then AD is equal to BC, opposite sides of a parallelogram, opposite sides of a parallelogram. Then BD is equal to AC. Already given that diagonals are equal. Now look, by SSS congruence rule, by SSS congruence rule, triangle ABD and triangle ABC are equal. Triangle ABD and triangle ABC are equal or congruent. Triangle ABD congruent to triangle ABC. Triangle ABD congruent to triangle ABC. If both triangles are congruent, then by CPCT we can say that corresponding parts are equal. Now I am rubbing these conditions. These are our assumptions. Now we got both the triangles are congruent. For congruent triangles, corresponding parts are equal. So what is the corresponding parts of both these triangles? we are considering these two triangles, then this angle and this angle are equal. These two angles are equal. Then which are the corresponding in both the triangles? These two angles are equal. Otherwise, we can simply say that these two angles are equal. For when we are considering triangle ABD and triangle ABC. So we can say that these two angles are equal. Then we know that for a parallelogram, opposite sides are equal and opposite angles are equal. And for a parallelogram, we know that opposite sides are equal and opposite angles are equal. Then the sum of the angles should be 180 degree and these two angles are equal. Therefore, we can say that each angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degree. So, from the property of a parallelogram, we know that opposite angles are equal. Opposite angles are equal. So, we can say that if both these angles are equal, then it will become 90 degree. It will become 90 degree. Okay, clear? I can explain once more. So, I'm just rubbing this figure and explain simply once more. Okay. Then if there is any doubt, you can clarify. If there is any doubt in this figure, I am just drawing it once more. A, B, C and D. This is the diagonals. And meeting point of the diagonal is taken as A. The only condition we know that diagonals of the parallelogram, these diagonals are equal. That means we know that AC is equal to BD. AC is equal to BD. Then what is the condition? We know that the diagonals of a parallelogram bisect each other. The diagonals of a parallelogram bisect each other. That is a condition we know. That means AO is equal to CO, DO is equal to BO. These all fours are equal. Now, how will we prove? This is a rectangle. For a rectangle, we know that all the four angles should be right angles. All the four angles should be right angles. Either we can take triangle ABD and triangle ABC. Triangle ABD and triangle ABC. Otherwise, we can take triangle AOD and triangle COB. When we are taking triangle AOD and COB, we got vertically opposite angles are equal. Then opposite sides are equal. Then these diagonals are equal. If they bisect each other, then these are also equal. So these two triangles are congruent. Either we can prove that, otherwise we can take triangle ABD and triangle ABC. Either you can take as your wish. When we are taking these two triangles, then these two triangles are congruent. Then these two triangles are congruent. By CPCT, we can say that this angle and this angle are equal. That is, these two are equal. Clear? Any doubt? Then by the property of a parallelogram, or we know that these two sides are parallel. For these two sides are parallel, alternate interior angles are equal. Therefore, if this is x, this is also x. So when considering these two sides are parallel, then this is the transversal. Alternate interior are equal. Then we can say that if this is x, this is also x. Clear? Okay. Now, for this triangle, we know that sum of the angles is 180 degree. So this is x, and what is this angle? These both are equal. That is 180 minus 2x. This angle is 180 minus 2x. Then this is also 180 minus 2x. Clear? Any doubt? So sum of the all four angles is 360 degree. Then what is these two angles? This is 180 minus, that is 360 minus 180 minus 2x plus 180 minus 2x. That is 180 plus 180, 360 minus 2x plus minus 2x, that is minus 4x. That is 360 minus 360 plus 4x. 360 cancels each other. Total of these angles is 4x and this becomes 2x. This becomes 2x. Now we got all the angles. Now we got all the angles. Okay. Then what we will do next? This angle is 2x, this angle is 2x, this is 180 minus 2x, this is 180 minus 2x, this is x, 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 x. Then what are the conditions we can take? Now if we take these two triangles, if these two triangles AB and CD are equal, that is opposite sides of a parallelogram, and the diagonals are equal and the diagonals bisect each other, therefore we can say that OB, OD, OA and OC are equal. OB, OD, OC and OA are equal. Then these two triangles are also congruent. For congruent triangles, corresponding angles are equal or corresponding parts are equal by CP/CT. So which are the corresponding parts? This angle and this angle are equal. If it is y, then it is also y. Then we can say that considering these two parallels, these are alternate interior angle, then this is also y, this is also y. Clear? So what is y plus 2x? We can say that y plus y 2y plus 2x is equal to 180 degree. This is a triangle. Y plus y 2y and this is 2x. So what is x plus y? X plus y is 180 by 2. It is 90 degree. What is x plus y? It is 90 degree. Look, all the coordinates we are having x and y. X plus y is 90 degree. That is simply proved. Clear? So this is something more simple. This method is simple. How will we prove this? Just taking first these two triangles. In these two triangles, opposite sides of a parallelogram are equal. Therefore, AD is equal to, we can say AD is equal to BC. Then we can say that AO is equal to CO and BO is equal to DO. Therefore, all these sides of these two triangles are equal. Then this will be congruent triangles. For congruent triangles, you all know that corresponding parts are equal. That is, corresponding angles are equal. This angle and this angle should be equal. So if this is x, this must be also x. Then consider these two parallel lines. When considering these two parallel lines, alternate interior angles are equal. Therefore, if this is x also. Then if this is x also. Clear? Now, these two angles are x. Then the third angle of this triangle must be 180 minus 2x. This is also 180 minus 2x. All the four angles, sum of all the four angles is 360 degree. That is, this 180 minus 2x, 180 minus 2x and both these angles should be 360. Therefore, we got these angles as this is 2x and this is 2x. Clear? Okay. Then consider these two triangles, triangle AOB and triangle COD. In these two triangles, opposite angles are equal and all the parts of the diagonals are equal. Therefore, these two triangles are also congruent. For these two triangles are congruent by CP/CT, we can say that if this angle is y, then we can say that this is also y. If this is y, this angle is also y. Then using parallel and transversal theorem, if this is y, alternate interior angles are equal, then it is also y. If this is y, it is also y. Now look, in this triangle, both the angles are y and this is 2x. You all know that sum of the angles in a triangle is 180 degree. That means y plus 2x. This y plus 2x is equal to 180 degree. Y plus 2x is equal to 180 degree. So that is 2y plus 2x is equal to 180 degree. Then what is x plus y? These two can be taken as common and that is 180 by 2. It is 90 degree. So in each corner we got x and y, that is x plus y is equal to 90 degree. Therefore, this is 90 degree, this is 90 degree, this is 90 degree and this is 90 degree. If all the four angles are 90 degree, then this is simply a rectangle. Then this is simply a rectangle. I think this is the most suitable way. At first, we are taking A, B, D and A, B, C. These two triangles, A, B, D and A, B, C. In that way also we can solve. Just forget that method and follow this method. This is more simple. Second method is more simple. I showed you first method, taking triangles ABD and ABC. That's the first method. And then the second method, taking the four triangles and by solving using x and y angles, it will be x and y. Any method you can take method 1 or method 2. I think you can solve it more easily by method 2. That we got the answer as x plus y is equal to 90 degree and these are x and y. Clear? Any doubt? Just try to solve it by method 2, then it will be easy for you. Okay, clear? Now moving to the last theoretical portion of this chapter, that is midpoint theorem. What do you mean by midpoint theorem? The midpoint theorem states that the line segment joining the midpoints of two sides of a triangle is parallel to the third side. The line segment joining the midpoints of two sides of a triangle is parallel to the third side. That simply means when we are considering a triangle, and this is our triangle A, B, C. This is our triangle. And when we are considering this triangle, the line segment joining the midpoints of two sides. So, I am taking this P as midpoint of AC and Q as midpoint of BC. When I join this PQ, that means midpoint of AC to midpoint of BC. Then this line PQ must be parallel to AB. This line PQ must be parallel to AB. This is midpoint theorem. If a line segment joins midpoints of two sides of a triangle, then that line segment is parallel to the third side. So P is the midpoint of AC and Q is the midpoint of BC. P is the midpoint of AC and Q is the midpoint of BC. So when this P and Q joins, that means we got a line segment PQ, then this PQ is parallel to AB. Then this PQ is parallel to AB. Clear? In other ways, we can state this midpoint theorem as if PQ parallel to AB, then P and Q are the midpoints of AC and BC. If PQ parallel to AB, then P and Q are the midpoints of AC and BC. That means if a line segment is parallel to one of the sides of the triangle, then the endpoints of these line segments are the midpoints of other two sides. This is simply midpoint theorem. This is simply midpoint theorem. Now look at the last question of this chapter. The question is ABCD is a quadrilateral in which P, Q, R and S are midpoints of the sides AB, BC, CD and A. AC is a diagonal that's shown in the figure. Show that first question is SR parallel to AC. We have to prove SR is parallel to AC and SR is 1 by 2 AC. That means half of AC is SR. Next, we have to prove PQ is equal to SR. Next, we have to prove PQ is equal to SR. Then PQRS is a parallelogram. Then PQRS is a parallelogram. These three things we have to prove. This is the figure. Now, what all things we have in the given condition? S is the midpoint of AD. Then P is the midpoint of AB. Q is the midpoint of BC and R is the midpoint of R is the midpoint of CD. These four things are given, that is S is the midpoint of AD, P is the midpoint of AB, Q is the midpoint of BC, and R is the midpoint of CD. These things are given. Okay. Now, first we have to prove SR is parallel to AC. First we have to prove SR is parallel to AC. How will we prove this? Now look at the triangle ADC or ACD. In triangle ADC. In triangle ADC, S is the midpoint of AD and R is the midpoint of CD. S is the midpoint of AD and R is the midpoint of CD. Now by midpoint theorem we know that when the midpoints of two sides of a triangle are joined by a line segment, then that line segment is parallel to the third side. That is, S is the midpoint of AD and R is the midpoint of CD. These are the two sides of a triangle, and when these two midpoints are joined together, it must be parallel to the third side. That is, by midpoint theorem we can say that AC parallel to SR. So by midpoint theorem, we can say that SR parallel to AC. SR parallel to AC. That's our first condition. Now then what we have to prove? This SR is 1 by 2 AC. Now we have to prove the value of SR is half of AC. Now we have to prove this SR is half of AC. For this, just consider two triangles, that is, consider triangles ADC and triangle SDR. ADC and triangle SDR. Look at this triangle. Is there any peculiarity for these two triangles? Yes, there is some peculiarities. That is, we know that SD is equal to half of AD because S is the midpoint of AD. Because S is the midpoint of AD. Therefore, we can say that SD is equal to half of AD. Then look at the next side. We can say that DR is equal to half of DC. DR is equal to half of AC. Now, what is the third side? From this, it is clear that triangle ADC and triangle SDR are similar triangles. From this, it is clear that triangle ADC and triangle SDR are similar triangles. For similar triangles, the ratio of sides must be equal. For similar triangles, the ratio of sides must be equal. That is, SD is equal to half AD, DR is equal to half DC. For the ratio, that means SR is equal to half AC. For this, SR should be equal to half of AC. SR should be equal to half of AC. That means SD, that is the side of smaller triangle. First side of smaller triangle is half of the first side of larger triangle. Then second side of smaller triangle DR is half of the second side of larger triangle DC. Then for similar triangles, ratio sides should be same. So for third side also, the third side of smaller triangle SR should be half of the third side of larger triangle AC. That means SR should be equal to half of AC. Clear? Now, what is the second question we need to prove? Second question we need to prove is PQ is equal to SR. Second question we need to prove is PQ is equal to SR. How will we prove PQ is equal to SR? Now, look at this triangle in the downward, that is ABC. Look at the triangle that is ABC. Now we all know the condition that SR is equal to 1 by 2 AC or half AC. Now consider triangle ABC. Now consider triangle ABC. We know that P is the midpoint of AB. P is the midpoint of AB. And Q is the midpoint of BC. Q is the midpoint of BC. So when we draw P to Q, then the line segment should be parallel to AC. Then the line segment should be parallel to AC. Then the line segment should be parallel to AC. That means PQ parallel to AC. PQ parallel to AC. PQ parallel to AC. Then we can say that PQ parallel to AC. Clear? Okay. Then the same condition we used in the first question, that is P is the midpoint of AB. Therefore, we can say that PB is equal to 1 by 2 AB. Then Q is the midpoint of BC. Therefore, we can say that QB is equal to 1 by 2 BC. Then from this similar condition, same condition, triangle ABC and triangle PBQ are similar triangles. So for this, PQ should be equal to 1 by 2 AC. PQ should be equal to 1 by 2 AC. Same condition as that of the first. Now we got PQ as half of AC. Now we got PQ as half of AC. Then look at the values of SR and PQ. SR is equal to 1 by 2 AC, that is half of AC, and PQ is also half of AC. Then we can say that therefore SR is equal to PQ. Therefore we can say that SR is equal to PQ. SR is equal to PQ. Now the second question is also solved. Third question, we have to prove PQRS is a parallelogram. Third question, we have to prove PQRS is a parallelogram. PQRS is a parallelogram. How will we prove? Already we know that PQ is equal to SR and PQ parallel to SR. How PQ and SR are parallel? Because SR is parallel to AC and PQ is parallel to AC. If two line segments are parallel to a common line segment, then these both lines are parallel. So PQ is equal to SR and PQ is equal to SR and PQ parallel to SR. That means one pair of opposite sides are equal and parallel. Now we need to prove this PS and QR are equal and parallel. For this I am drawing the second diagonal, which is BD. For this I am drawing the second diagonal BD. Now consider the triangle. Triangle ABD. Triangle ABD. In triangle ABD, we know that P is the midpoint of AB and S is the midpoint of AD. So from the midpoints of these two sides, when we draw a line, this line is parallel to the third line or the third side. So by midpoint theorem, we can say that PS parallel to BD. PS parallel to BD. So from the first condition, same conditions are checked again. Considering the triangles ABD and APS, ABD and APS, we know that AP is equal to half of AB. AP is equal to half of AB. And AS is equal to half of AD. Then this APS and ABD should be similar triangles. Therefore, the third side should be in the same ratio, that is PS is equal to half of BD. PS is equal to half of BD. Now consider the triangle in the other side, that is triangle BCD. Triangle BCD. From it is clear that Q is the midpoint of BC and R is the midpoint of CD. When we join this Q and R, this should be parallel to the third side, that is QR parallel to BD. QR parallel to BD. Now again consider the triangles BCD and QCD. We know that QC is equal to half of BC and RC is equal to half of CD. Then these two triangles are similar triangles and the ratio side should be same. For the third side, it can be said that QR is equal to half of BD. So now look at the values. PS is equal to half of BD and QR is equal to also half of BD. Then we can say that PS is equal to QR and also PS parallel to QR. Now look at both the conditions. PQ is equal to SR and PQ parallel to SR. That means opposite sides are equal and parallel. Again, PS is equal to QR and PS parallel to QR. Next pair of opposite sides are equal and parallel. So, all the opposite sides are parallel and equal. Then we can say that PQRS is a parallelogram. Then we can say that PQRS is a parallelogram. That's the third question. Show that PQRS is a parallelogram. Okay. Now we solve all the three problems. That is SR parallel to AC proved, SR is equal to half AC proved, PQ is equal to SR proved, PQRS is equal to a parallelogram proved. Now I think the chapter is clear to you. In this chapter we studied about quadrilaterals, what is the peculiarity of quadrilateral, types of quadrilaterals, angle sum property of a quadrilateral. Then most important thing is that properties of a parallelogram. And based on that properties or that theorem, we solved some problems. Then the last topic is midpoint theorem, and this problem is related to the midpoint theorem. I think everything is clear to you. If any doubt, if you are having any doubt, then go through the section again and try to solve this problem or solve any other problems again. Then you will be able to solve all the problems related to the chapter. Just go through the theory section again and solve it again. Okay, I am Nitishas and thank you for joining me in this section. Let us meet you with another section in another day. Okay, thank you all.